Hey class, this is your lesson while I am absent on Monday, 12/6. We're going to be going over 6.6 today. Throughout the lesson, I'm going to ask you to pause and complete the problems or complete activities and then come back to the video. So for instance, I want you to do this bell work right here. And in order to do that, you're going to need to pause the video and then we'll go over it together. All right, awesome. Hopefully at least a few of you pause and follow the directions. I would appreciate that. So it looks like we have a shadow cast by a 4-foot tall female ostrich. So the ostrich itself, you guys know from my Christmas art gallery that you might have saw last week, I am not exactly the most talented drawer, but we know that this ostrich is 4 feet tall and its shadow is 10 feet long. So 10 feet. And the word on the street is there's a taller ostrich. We know he's taller because the shadow he's casting is 15 feet. Those legs, those are a little bit weird looking. So the shadow he's casting is 15 feet. So he's going to end up being taller than the other ostrich. All right, so we got to set up and figure out the height of this ostrich. So to do that, there's a couple ways you can do it. We're going to go by creating ratios based on the corresponding sides and then turning that into a proportion. So for instance, these two sides correspond, right? They're both the heights of the ostriches. So they can go in the same ratio. I'll put the males unknown above the females known. And here, let me actually highlight that for you guys. There's the males unknown and the females unknown, and I'll rewrite it in that color. Then over here, we got the male's shadow, so that's going to line up with his height, and the female shadow is going to line up with her height, right? So notice how male's height and male's shadow, they're lined up, right? Female's height and female shadow is lined up. Proportional sides create a ratio. So we're just making sure everything's lined up so that we do this correctly. Now you just got to cross multiply. You end up with 10x equals 15 times 4 is 60. We can divide 10 on both sides, and you probably figured that out. It is 6. So this ostrich is 6 feet tall. Very good. All right. Notice how we're going to go through the unit outline. We'll get through lesson 6.6, and then there's a quizzes at the end that you can do. Okay, so you have homework tonight. I'm going to actually be giving you guys a homework helper video where I go through a couple of the problems that you might be struggling with, so you can use that if you need to. Tomorrow we're going to have a fun in-class project, and then for 7th grade, your test is Wednesday, but noticeably we're reviewing right beforehand, same thing with 6th grade, and then of course your midterm reviews start after that. So I'll be giving you a study guide to complete that will help you study for the midterm if you're taking it. Notice how 6.6 skill drawings are a lesson, and we have to use proportions, just like we just did. We just used proportions right there, but we're going to use it with scale drawings. We got to figure out what scale drawings are. All right, that's a lot of notes. So go ahead and pause right here to take the notes that are right here. So the stuff that is italicized, those are the notes you need to take. So go ahead and pause. Okay, hopefully you guys paused, took the time to write that down. All right. A scale drawing is two-dimensional and is similar to the object it represents. A scale model is a three-dimensional model that is similar to the object it represents. Basically, a scale drawing is a smaller version of something that it's representing. So for instance, a map. Right, here's a map. A map is obviously much smaller than whatever it's representing, right? This little pyramid right here on the map is tiny, but the pyramid in real life is going to be huge. So a scale drawing is representing something much bigger. And the same thing with a scale model. Think of like a toy car. A toy car is tiny. A Hot Wheels is tiny, but it's representing something much bigger. So it's a tiny version of something a lot bigger. The scale of a scale drawing or scale model gives the relationship between the drawing or model's dimensional and the actual dimension. So for instance, the scale of this map is 1 centimeter, it says right here, 1 centimeter to 200 meters. What that's saying is on the map, if you go 1 centimeter on the map, you're really going 200 meters in real life. Or if, let's say we have the toy car example. So we got the toy car. Again, I'm just drawing really quick. Looks more like a skateboard. Let's pretend that's a car, though. There you go, car. If it was a toy car, every foot, or every inch, I should say, represents maybe a foot in real life, or something like that. Basically, it's just like, hey, that toy car is really tiny, so every centimeter represents a foot, or every inch represents a foot. You get the point. Basically, the scale just tells us how to relate this to what it actually is. Now, let's see how we do that. Okay, on the map, the center of the pyramid of the sun is 4 centimeters from the center of the pyramid of the moon. So, right over here, the pyramid of the sun center is 4 centimeters from the pyramid of the moon. So that is centimeters. That's how far it is, 4 centimeters. What is the actual distance from the center of the pyramid of the sun to the center of the pyramid of the moon? So we know, So we know that on the map it's 4 centimeters. So we got to figure out, what is it actually, in real life, if you were to go there, how far would it actually be? What we do is exactly what we did with the ostrich. We take proportional relationships, or in other words, ratios, and we make them equal to each other, and then that becomes proportional, and we can solve it. So, we take our scale. Our scale here is 1 centimeter for 200 meters. That's a ratio, so we can write it as a fraction. 1 centimeter for 200 meters. I like to include the measurement so that I can stay organized. And then we know that on the map we're going 4 centimeters, but we don't know how long that is in real life. So notice, I've got centimeters, they're lined up together, right? This ratio is together just like it is on the map, and this is what we know and we're trying to figure out, so that's why they're together. And now you just do what we've always been doing, you solve the proportion. You've got 4 times 200 is 800, and you got 1 times x is just x. So if you travel 4 centimeters on the map, you're traveling 800 meters in real life. Let's keep going. Why don't you guys go ahead and pause for this one and see how you do. All right, hopefully you paused. It's saying that on the map, the pyramid of the sun has a length and width of 1.1 centimeters. Find the actual dimensions of the pyramid of the sun. So it's saying that this width right here is 1.1, and this length right here is 1.1. Now, you might be thrown off. I hope you didn't think that it meant that you were trying to find 2.2. You don't add them together. It's just saying, it's 1.1 times 1.1. So we only really need to find one of those, since they're the exact same. We only need to find one of these in order to solve the problem. So, same as before. We got our scale. That's a ratio, so we're going to keep it together. 1 centimeter over 200 meters. Again, we've been given the map's actual distance. So on the map, it's 1.1 centimeters. We want to know what it's like in real life. So that's what we don't know. Notice how centimeters are lined up, ratios together. We're all good to go. We got 1.1 times 200, 1 times x. That's super easy. That means it's just going to be x equals, and 1.1 times 200. I feel like I should know that off the top of my head. I'm going to pull out my calculator. 220. Come on, Mr. Bohr, you could do that. So, in real life, that pyramid is 220 meters by 220 meters. So again, use the scale to find the missing length. Let's look at what it's like, not just for a scale drawing, but a scale model. So something that's 3D. Pretend like that is an actual 3D space shuttle. A model of a space shuttle, so a small version, probably a toy space shuttle, has a scale of 1 to 52. The space shuttle has a wingspan of 78 feet. Find the model's wingspan. So we want to know, if that's the real spaceship and its wingspan is 72 feet, what's the model's wingspan? Again, let's take the scale, 1 to 52. Now, it doesn't tell us inches or centimeters or anything like that. But what it does is it says, hey, you know the actual is 78. And keep in mind, if it's a toy, it's going to be really tiny, right? So the 1 represents the tiny little toy, and so that's why it's lined up with the X. And then the actual is 52. It's 52 times bigger than the toy, so that's lined up with the actual wingspan that we know. Then we cross multiply. We're going to get 52x equals 78. We divide by 52. X equals 78 divided by 52. I'm going to pull out my calculator. I get 1.5. So it looks like the actual is 78 feet. The model is 1.5 feet, which makes sense, right? A toy model spaceship would have a 1.5 foot wingspan. Let's keep going. Go ahead and pause right here and try and solve both of these problems. All right, for the first one, we notably are still working with our space shuttle. The length of the space shuttle, the actual space shuttle, is 122 feet. We still are using the same scale as before. So that's easy. 1 over 52. We know the actual is 122. We want to find out the model. Again, that 1 is representing the model because it's 52 times bigger in real life, and so the real life is lined up with that 52 times bigger. We're going to end up with a pretty similar equation, what we just did. We got 52x equals 122. Probably going to pull out the calculator. 122 divided by 52 is 2.3461. That's a lot. So we're just going to round to the nearest tenth, and I think you could round that up to 2.4. If you got 2.3, don't feel too bad. You're fine. So the actual length is 122 feet. The model's length is 2.4 feet, which makes sense. The model should be smaller than the actual. Okay, we got another one. We got a model sailboat over here. That's cool. And its scale is 1 to 20. The actual sailboat is 32 feet long. How long is the model? That's actually the same exact problem we really just did. We got a 1 to 20 scale. We don't know the models. We know the actual sailboat is 32 feet long. So we go ahead and solve the proportion. 20x equals 32. 32 divided by 20 is 1.6. So the model's is 1.6 feet, which makes sense, right? The model should be way smaller than the actual sailboat. Okay, moving on. Every few years, the Grand Palace, that shouldn't be placed, the Grand Palace in Brussels, Belgium, is decorated with a large floral carpet made of begonias. It's a really fun word to say, begonias. This is it right here. That's our Grand Palace. Suppose the floral carpet is to be 40 meters wide. A designer creates a scale drawing of the carpet that is 20 centimeters wide. Find the drawing scale. So what we're doing is the opposite of what we did up here. Not the opposite necessarily, but up here, they gave us the scale. Down here, we're creating the scale. And they pretty much just lined it right out. We know one side is going to be 20 centimeters. And that same side in real life is going to be 40 meters. So to make it a scale, all we have to do is simplify that to 1 over 2. So let's say right here, this side is 20 meters in real life. Oh no, my bad. 40 meters in real life. On the actual, or on the drawing, it's going to only be 20 centimeters. That way then, when they go to do this side, let's say in the drawing, they make that 80 centimeters. Well, we know that then in real life, it's going to be 160 real meters. So making the scale super easy. Let's go ahead and pause right here. See if you guys can solve this one. All right, we got Mike. My sixth graders know that this right here is Mike Bettaducci. Mike's map shows a bicycle route that is 112 miles long. On his map, this distance is 14 inches. What is the scale of the map? Okay, we got our 14 inches. That's what the map would be. 112 miles would be what it is in real life. So if we were to simplify that, we would divide by 14. You want to make, I should have mentioned this before, that's my fault. We want to make it so that the top number here, the scale is a 1. So we want to change that 14 to a 1. How do we do that? We divide by 14. So 14 divided by 14 is 1, and 112 divided by 14 is 8. So we get a 1 to 8 ratio. Everything on the map is 1 to 8 in real life. 8 times bigger in real life, in other words. Okay, this is a pretty simple lesson. We're actually at the end already. I'd encourage you to do this quizzes and then get working on your homework. Now, the homework is is a little bit different than we're used to. It's a lot of pictures and pictures of scale drawing, scale maps, scale models, which is fun. But it is going to take a little more time. That's why the lesson itself is short, but the homework is going to take some more time. So as soon as you finish this quizzes right here, get to the homework and get working.